Electricity is a fascinating topic to me. It covers some basic ideas to do with static electricity, positive and negative charge. It looks at simple circuits, electron flow. It covers abstract ideas to do with energy flow around a circuit. And in A level, we get to look at some quite complex circuits. Beyond A level, then we could be looking at wave behavior, or we could be looking at particle behavior of electricity. So there's a lot to cover, but what we're going to be focusing on at the moment is static electricity. Let's start with charge. I would love to tell you what it is, but I can't. Not really. It's so fundamental to physics and our universe that it is hard to really explain. But what I can talk about is how it behaves, and actually, that's all we need. Objects, particles, can have one of three states. They can have a positive charge, a negative charge, or no charge at all, neutral. Having a positive charge simply means that the particle is repelled by other particles with a positive charge, but attracted to other particles with a negative charge. And similarly for a particle with negative charge. Like poles repel and opposites attract. That's what it means to have charge. That's important, so a quick recap. Particles can be positive, negative, or neutral. Like charges are going to repel, but opposite charges are going to attract, and neutral has no effect. Now then, moving to the real world, which particles are charged? Materials are made of atoms, and atoms are made of a positively charged nucleus at the center and negatively charged electrons surrounding the nucleus. In an object, a table or a book for example, the object is solid because the nuclei are all held together in a fixed grid, which we call a lattice. The nuclei are held tightly in place so they cannot move. The positively charged nuclei are fixed in place in the lattice and cannot move. The electrons, however, the negatively charged electrons, can move around, especially in a metal. So, for charge to move, it will be the electrons, the negatively charged electrons that move. We're not getting to electrical circuits yet, so instead we're going to generate some static electricity. This balloon has no charge. Actually, that's a lie. Sorry. The balloon has a lot of charge because it has billions of nuclei and billions of electrons, so it has lots of positive charge and lots of negative charge. But normally, the total positive charge is equal to the total negative charge. So the total charge adds up to 0. We say it has no charge. So, okay, this balloon has no charge. That was kind of important because what I'm going to do now is rub the balloon on this person's hair. When materials rub like this, electrons, which are free to move and are negatively charged, jump from one material to the other. There are some rules for which way they go, but I never remember them. It's not important, but let's say the electrons move from the head to the balloon. The head used to have 8 positive charges and 8 negative charges, but now has 8 positive charges and 2 negative charges. It is positively charged. Meanwhile, the balloon used to have 8 positive charges and 8 negative charges, but now has 8 positive charges and 14 negative charges. It is negatively charged. Note that I drew this carefully, so we still have the same total number of charged particles. This is static electricity. The objects are charged, but the electrical charge is not moving. It is static. Next, we can do something clever. Well, you'll have seen this before, I expect, but it is quite clever when you understand it. If we take this balloon, the one with a negative charge on its surface, and we take it near a wall, the negative charge in the surface of the balloon repels the negative charge in the wall, pushing it away. It also attracts a positive charge in the wall, but the positive charge is fixed in the grid, in the lattice, so it cannot move. The balloon can move though, and it is attracted to the wall and sticks there. The excess charge in the balloon is attracted to the positive charge at the surface of the wall, and they stick together. And that's the key information that you need to know for static electricity. The positively charged nuclei are held in a fixed lattice. The electrons, particularly in a metal we're talking about, are free to move and carry the negative charge. When we say that something is neutral, what we're really meaning is that there's the same amount of positive and negative charge. If we want to make something positively charged, then we should remove the electrons away from it. And if we want to make something negatively charged, then we add electrons to it. And it is only, and it is always, the electrons that move.